Alright guys, let's try to solve leetcode 1493, longest subarrays of 1's after deleting one element. So given a binary array, nums, as you see in this table, array on the right, you should delete one element from it. Return the size of the longest non-empty subarray, okay. Containing only 1's in the resulting array, return 0 if there is no such subarray. Okay, so if you look at the example, you see that this is because you delete the 0 here, you have 1, 1, and 1, which is where you get 3. And here, I think you get 5 because, let's see, the biggest sequence I can think of is this. And you see that you have 1, 1, 1, 1, 1. And if you get rid of the 0, you get a continuous. So I think the subarrays being continuous sequences, right? So from this, I immediately just think of, okay, I want to group as much 1's as I can together. So my first instinct, okay, so 1, how many 1's do we have here? So this has maybe 3. No solution yet, but I'm just trying to see if I can get anything from this analysis. 2, and this is just 1. So somehow I want to connect this 3 and 2 into just one entire subarray, which would entail me adding these two, and that would net me, a total of, let's see, 5. But the question is, where do we exactly make these divisions come true? So how I figured it out was basically you can only remove 1, 0, right? So that means that at a certain subarray, I think every single subarray is going to contain 0, right? So this right here contains this 0, and maybe this also contains a 0. So what I realized is that what if we go along the array using a sliding window and we keep track of the longest subarray length that has just 1, 0 or less, because that means that even if we do encounter, so for let's say I'm making a subarray here, I see 1, 1, 1, and even if I see a 0, if from the entire beginning of the subarray I've only seen 1, 0, then I can still continue onwards. So I would stop here, because the moment I enter here, this would be 2 zeros, then we would want that. So I think that's going to be our limiting factor, where if you realize that there's more than 1, 0, then we climb all the way up here and we change this as the left, and we continue updating our window. So that's kind of logic here. Basically, we use a sliding window, and we keep expanding our window. This is huge. As long as there is only 1, 0 in the subarray. Yeah, so this is going to be our basically our bottleneck. So let's try to implement this real quick. Okay, so when we're solving these kinds of problems, you want to have a left and right. So left is going to be the leftmost part, and right, which is going to be our rightmost, is going to be our index as we iterate through the array. That's just going to be our indexing factor of the array. Let's do n is the length of nums. And what else do we need? We need the 0 count, because remember, we want to make sure that the 0 count is always less than 1. And let's see, let's iterate through for a right in range of n. Okay, so if in our current value, if it's equal to 0, then we first, regardless of whether we've had 2 zeros or 1, 0, we still have to increment it, right? That's the first thing we need to do. So we're going to get let's see, if nums of right is equal to 0, then our 0 count increments by 1. So from here we have two choices. Is if our zero count is greater than 1, which, so for example, this was left, whoop, this was left, let's do a different color, right? This was left, and now we just got here. We just realized that there's two zeros, right? So we have to do something. We have to update. We have to shift this left towards here. So how are we going to do that? So how we're going to do that is basically first set the condition if zero count is greater than 1, right? So we're going to, and the common loop is while our left index is less than our right index, so we don't want to go outside of the window, right? And our zero count, this is important, zero count, our current zero count is still greater than 1. If we still have more than 1 zeros, what we're going to do is we're going to see if our leftmost was indeed a 0. Because if not, then we keep, because if this was just a 1, right? If this was 1, then we would have to keep going until we find some sort of 0 eventually, right? And so what we're going to do is, okay, hey, is our leftmost value equal to 0? And if it is, we, hey, we found what we needed to erase, and we decrement 0 count accordingly. And if not, well, you have to just keep going to the right? So that's going to, so this is going to help us shift our leftmost to the first non-zero part of the window, or until we get to the end of the, until we get to right. Okay. What else? Yeah, this should be it. And after that, so after we exit this if loop, then our 0 count is going to be 1 as we desire, and you're going to keep shifting. You're going to no, not left. What we want is that after all this, we see that if we see what the best one is, and best distance is going to be, let's see, let me create a variable right here, best. Now best is going to be the maximum, so the biggest thing between the current best and our right minus left. And why it's right minus left not right minus left plus 1 is because if you see here, if our right was, let's see, if our right was here, if this was our right, the index of here is 0, and this index is 1, 2, and 3, right? So indeed the length between the left and right of what you want is indeed 4, right? Because 3 minus 0 plus 1 is 3 minus 0 plus 1. 3 minus 0 plus 1 is 4. But the thing is, we realize that we allow the inclusion of 1 0 already. But the question asks us, contain only 1's. So we have to subtract that minus 1. So that just simply becomes right minus left, which is 0 minus 3. And indeed, we only have 3 valid 1's in this window. So that's why it's right minus left. And after all that, I think if we just return best, this should give us the correct answer. And alright, that gets us the correct answer. And as for the time and space complexity, the time complexity is going to be O of n, because it's a sliding window problem. We iterate just once throughout the entire array, right? And in terms of space complexity, we don't really use any additional data structures. We just use variables, and that should also just be constant time O of n. And let's see if this is correct. Let's try submitting this. Alright, not bad, not bad. Yeah, I hope you guys enjoyed, and I'll see you guys next time.